Okay, so today we are starting a new chapter. It is chapter 6 called Systems of Equations. So the first thing we need to go over is what is a system of equations. A system of equations consists of two or more linear equations in the same variables. So we are going to now have two equations instead of one, so twice the fun. We're going to have more than likely an x and a y in one equation and then an x and a y in a second equation. Now, with those two equations, our job is going to be to find a solution that makes both of those equations in the two variables true. We know from the past that a solution is going to be an ordered pair. So we are looking for an x and a y ordered pair that will make our two equations in our system true. Okay? There are several ways that we can find this ordered pair solution. The first method we're going to go over today is by graphing. So we're going to do your favorite thing, which is graph. All right, so let's move on to the second slide. Okay, and our directions here say to tell whether the ordered pair is a solution of the linear system. We've done this before. Okay, I'm going to take the ordered pair that they give us, 25, and plug it into this system of equations to see if we get something that is true or not. So we all know that the 20 is the x and the 5 is the y. So first I'm going to test my first equation. And I'm going to say, is 20 plus 5 equal to 25? Well, we all know that that is true. But it is not a solution unless it makes both equations true. So now I need to test my second equation. I have 15 times my x, which is 20, plus 30 times my y, which is 5, and I'm going to see, does that equal 450? Okay, so my first problem, 20 times 15, gives me 300, plus 30 times 5 gives me 150. Does that equal 450? Well, in fact, yes, 450 equals 450, so that is true. Because this ordered pair right here made both equations true, we say, yes, it is a solution. Now, what if it only made one of them true? It would not be a solution. It has to make both equations true. All right, on to the next example. Now we are going to use graphing to see what the solution to these three systems are. So I have three examples here, 1, 2, and 3. We're going to work through these three separately. Okay, so what we did here is in this picture right here, they have graphed these two lines for us. How nice. Where do you think the solution to this system exists? Probably right here at the intersection of the two lines. So we need to know, what is that ordered pair? Well, it is the ordered pair 2, -1. So what I can do is plug in that ordered pair into both of my equations here and see if that's true. Well, 4 times 2 plus 3 times -1, does that equal 5? I get 8 minus 3. Is that 5? Yes. Plugging into my second equation, 2 times 1 is 2, minus 2 times 2, which is 4, minus a -1. Does that equal 5? 4 plus 1 is 5? Yes. So this point right here, the intersection, is the solution to my system, which is the ordered pair 2, -1. Okay, on the second example, again, they already have graphed the equations for us right here. I look at my intersection point. I see that the 2 points intersect. So I need to write down that ordered pair, which is -1, -1. You guys at home can plug in this ordered pair and make sure that it is true. Same thing for number 3. I find my intersection point right here. I see what that ordered pair is. It is 3, 4. So you guys plug in this value for x, this value for y, and make sure you get that true. And you will see that this ordered pair makes this system true. It makes both equations true. All right, now we're going to try one on our own. Here, they did not graph it for us, unfortunately, so we have to graph this system. Okay, first thing I need to do is graph the line 3x plus y equals 7. Well, bummer. Unfortunately, it is not in slope-intercept form, so I need to get it in slope-intercept form first. That gives me the equation y equals negative 3x plus 7. So I'm going to go ahead and graph that, starting with my y-intercept at 7, and then a slope of negative 3. Okay, so you guys at home could go ahead and graph this. Okay, I'm going to connect all my points with a line here. That is my first equation. Sorry, this smartboard's off a little bit, so I didn't hit my points exactly, but you get the point. Now I need to graph my second equation. Okay, so I need to get that one in slope-intercept form. If it's already in slope-intercept form for you, you lucked out, but we didn't. So I get the equation y equals 2x minus 8. I'm not going to review slope-intercept form. You guys know that. I'm going to graph y equals 2x minus 8, starting with my y-intercept of negative 8. Rise 2, run 1. Whoa, my black dot just hit my red dot. That's pretty important right there. I'm going to keep doing this, and I'm going to draw in that line. Now we learned from the last slide that the solution to this system of equations is where the two lines overlap, where they intersect each other. Okay, so I can see that my red dot and my black dot overlapped right there, intersected at this point. So what I need to do is I need to see what that ordered pair is. 1, 2, 3, down 2. So the ordered pair 3, negative 2 appears to be the solution where my red line and my black line intersect each other. What can we do to figure out if that's true? Plug in the x value of 3 and the y value of negative 2 into both equations to make it true. All right. So tomorrow I want you to know the answer to these two questions. Be ready to talk about it in class and be ready to practice what we just learned today and do lots of example problems tomorrow. Have a good night.